Hello everyone, and welcome to this theory video on source transformation. So, source transformation is a principle that allows you to convert between one configuration of a circuit to another configuration of a circuit. And the two configurations that you'll be working between would be that of a voltage source that is connected in series with a resistor that will be easy to convert between a current source that is connected in parallel with the resistor. So you can move from the voltage source in series with the resistor to a current source in parallel with the resistor and vice versa. It's important to note that the value of the resistance will match in the series connected voltage source and resistor case and the parallel connected current source and resistor case. So RTH is equals to RNO, which is equals to R. It's also important to note that the denotations of VTH, RTH, IN, and RN don't necessarily need to be that of the Thevenin voltage and the Thevenin equivalent resistance. This can be any value and any value. The principle of source transformation will still be applicable. Second, in order for you to determine the voltage, in this case denoted as VTH, if you've transformed from a current source in parallel with a resistor, you would need to multiply that current source with that resistor value. And likewise, if you had transformed from the series voltage source with a resistor and you need the value of the current, you know that the current will then equal the voltage obtained divided by the resistance, whilst R and O will match the resistance of the previous configuration. Right, so what are some of the things to take into mind when working with source transformation? The first thing to remember is that this is applicable for both independent as well as dependent sources. So I'm able to also do a conversion between a dependent voltage source to a dependent current source, where the value, let's call it IS, is going to give us VS divided by R. So that's the first important point. The second is, what is the objective of this transformation? It's important that we remember that the objective is always to simplify. If after your transformation you have not simplified your expression or your diagram, then you have done something wrong within your transformation, or you were not supposed to transform. So what will happen? How will we simplify? When I convert a voltage source in series with a resistor to a current source in parallel with a resistor, or vice versa, I should end up with one of two scenarios. The first scenario will be a circuit that will have multiple voltage sources. Say, for example, the circuit that's indicated. Let's say we say this is 10 volts, that's 15 volts, and let's say that's 40 volts. And in such a circuit, we then should be able to simplify. And how will we simplify this? We can reduce that circuit to just one voltage source with a resistor. How will we do this? I'll simply just add the values together. So if I started at 0 and I increased by 10, I'll be sitting here on positive 10. Then I decrease by 15, so I'll be sitting here on -5. And then I increase by 40, so I'll be sitting here on positive 35. So that will be a 35-volt source. If this was a 2 ohm resistor, that will be 2 ohms. And similarly, if I did a conversion from a voltage source in series with a resistor to a current source in parallel with a resistor, I may result in a circuit that may look as follows. Let's call it 10, 2, and 7. And what I should be able to note here is that I can simplify this circuit because I've got currents that are all connected to one node. So I can treat currents going into the node as positive and currents going out of the node as negative. So this can be simplified to one source and a resistor. The value of the source will be positive 10 plus positive 2 minus 7. So it will be 12 minus 7, which then gives us 5 amp. Therefore, we see that the whole objective should be to simplify the circuit expression. Thank you for watching this video and enjoy the course.